So we'll go on to the next example now. Maybe make this a little bit more challenging, although they're all pretty similar. Once you get the basics, they're not that bad at all. So this time we'll start with, we'll say you're given 103 grams of we'll go with aluminum. You're given 103 grams of aluminum, and we want to know how many moles. How many moles is this? And well, I guess we'll go with all of them. How many liters? How many liters is this? And how many atoms of aluminum are in 103 grams of aluminum? So, like we did before, we'll start with 103 grams, and remember, for grams, let's see if I can find it over here. For grams, when we're going moles to grams, we need to use the periodic table of element to find how many grams are in 1 mole. So since we have aluminum this time, aluminum, it is right here. Remember, it's this bottom number right under the elemental symbol. We have 26.982 grams per mole. So let's keep that in mind. Wait, what was that? That was 26.92. 26.982, I think, but 26.9 will do. So 26.9 grams per 1 mole. And this is grams right here. Grams. So this is a little bit different from the last one we did. I'll give you another analogy to help you understand this. So say there are 20 candies. We know that there are 20 candies per 1 jar. And say we're given 500 candies. 500 candies. And we want to know how many jars will it take. Well, this time we can't just multiply the number of candies, or we can't multiply these two numbers together, the 500 and the 20, because that'll give us a really large number, and we don't need that many jars because each jar will hold 20. So this time we have 500 candies. We'll just label that 500C, and each jar will hold 20 candies. So if we divide the number, or the total amount of candies by the number of candies that will fit per jar, we will be left with the number of jars we need. Which in this case will be 25 jars. 25 jars. So you can see it's a little bit different. Now we're not multiplying these two numbers, we're dividing it. So we can write it like this instead. We have 103 grams of aluminum, and now in 1 mole, there's still 26.9 grams. And I'll explain the units this time too. Before I was just showing you the basics. When we multiply this fraction, you have to keep into account the units are being multiplied together as well. So this, let me box this off. So 103 grams times 1 mole per 26.9 grams, well, that's just equal to, in simplified forms, 123 grams times a mole, because there's only one. It's implied that there's a 1 there. And that whole thing is divided by 26.9 grams. And what do you notice is that the grams will actually cancel out, right? Because there's 1 on the top, 1 on the bottom. And in terms of units, there's 1 gram unit on the top and 1 gram unit on the bottom. So those two will cancel out, and now we can just divide, which will leave us with 103 divided by 26.9. That'll leave us with 3.83. And as you can see, we're left with the mole, the unit, the mole. So we carry that to our answer, right? Because there's nothing that you will cancel out the mole, so it carries over to our answer. And like I said, that is our answer. There's 3.83 moles and 103 grams of aluminum. And these are equivalent. 103 grams is the same thing as 3.83 moles. It's important to understand that. Like, some students will think that this is just some completely random number that we're using, but these are the exact same things. We're just using two different units to describe them. So that's done. We'll go to liters now. Go to liters now. And 103 grams of aluminum, how many liters are there? How many liters are there? Well, if we go back to our mole road over here, we see that you can go from grams to moles. By the way, all these are double-sided. You can go from liters to moles and grams to moles. You don't have to go from moles to grams only. You can go from the number of atoms to moles. And what I'm trying to say is, as you can see, we can go from grams to moles and moles to liters, but there's nothing that will let us go straight to grams to liters. There's nothing that will let us do that. So what we have to do is go from grams to moles. We can calculate this number, and since grams will be equal to the number of moles, then we can take this value and then go to liters. So we were given grams and we found the moles, and now we can take the moles and go to liters. So let's do that. So now we can just pretend that the question said you're given 3.83 moles of aluminum. How many liters are there? So we can take 3.83 moles, and we want to know how many liters are in it. Well, if we remember, there are 22.4 liters per 1 mole. And now we can just multiply these two numbers together like we did before. And as you can see this time, maybe a little more clearly, that the units, the moles, will actually cancel out, because there's 1 mole unit on the top and 1 mole unit on the bottom. And now we can just multiply these across. So 3.83 times 22.4 liters, that'll be equal to, let me box this off again, that'll be equal to 85.79. I don't know why I wrote an S there, it's just L. And as you can see again, the liters, since there's nothing to cancel it out, that'll carry down. We're left with 85.79 liters. So this is equal to 103 grams, and this is equal to 3.83 moles. Again, we're just using different units to express these values. So that's done, and now we just need to find the number of atoms. And to do that, we'll go with red here. To do that, we just need to use Avogadro's number, which, if you remember, we'll see, we'll answer this question. Can we use this value, this 85.79 liters, to go to find the number of atoms? And this is why the mole road is helpful, to draw it out this way. It illustrates it nicely. It's because, as you can see, everything needs to go through moles to convert it to another unit. So if we have liters and we want to go to grams, we have to first find out how many moles are in that liter, or in that amount of liters, and then use those number of moles to go to grams. And similarly, if we have the amount of liters and we want to go to the number of atoms, we have to first find out the moles. We have to first find out the number of moles, and then we can go to the number of atoms. So with that being said, the answer to the previous question is, or can we use liters to go to the number of atoms? The answer is no. We must first go through moles, which we've already found out. So it's always helpful, or it's actually necessary, to find the number of moles first before you want to go through anything else. But this number will allow us to traverse through the mole road, or travel through the mole road, and find these other values. So we have 3.83 moles of aluminum, and we can, or if we remember, in 1 mole, in 1 mole, there were 6.022 times 10 times 10 to the 23rd times 10 to the 23rd atoms. So there are this many atoms per a mole of any substance. In this case, it's aluminum. And now we can just multiply across, and that'll give us, well, there's one thing I want to mention is you may be wondering why I keep why I keep leaving off the E on mole. Like I did it here, here. And really the writing it this way, MOL, is just the shorthand. Writing it this way excuse me, is just the shorthand of writing it with the E. They mean the exact same thing. It's just like writing, you can either write L or you can write liters. They mean the exact same thing, so hopefully you didn't think I was terrible at spelling. So that explains it. So, as I said before, we can just multiply these two numbers together to find the total number of atoms. And once again, you'll see that the moles cancel out here, and the moles cancel out here, and we'll be left with atoms, which is the unit we're looking to find. So that's always a nice way to double check that you're multiplying these two the right way instead of having the mole on top and dividing by the number of atoms. The units that aren't in the answer you're looking for should always cancel out, and you should be left with the units that you are looking for. So in this case, we did it correctly. So 3.83 times 6.022 times 10 to the 23rd is equal to 2.3, roughly 2.3 times 10 to the power of 24. Again, the atoms will carry down. So those are the units in our answer. And this is our answer, 2.3 times 10 to the 24th atoms. So there are that many atoms and 103 grams of aluminum. And that's pretty much the mole road for you. I mean, maybe the only tricky part is remembering whether to multiply, say multiplying 103 times 26.9 or dividing 103 by 26.9. But then again, the trick is that your units should always cancel out. The units that you don't want in the answer should always cancel out. So as you can see, the grams here canceled out, and we are looking for moles. The first one was moles, and we were left with moles. So that's the trick to figure out whether you're multiplying them together, right? And that's pretty much the mole road for you. I'll see you in the next set of videos.